Down the last video that I didn't upload because it was too long into a smaller piece. Okay, so still talking about modeling. I wanted to show you another thing, which was okay. So if I want to get this this edge here, this little lip, to get closer, I could either like kind of guesstimate what it should be like, or remember we had our normal and global, but normal won't work here. Sorry, our local and global. Local here won't work for this edge. It's a compound edge. It doesn't really know what the local is, so we're going to use normal. And normal, like the normal lines, is every line that is vertical, that is perpendicular to a surface. So here we go. I think so if you take the cross product, I think, of two vectors, you will get a vector that is perpendicular to, so basically the cross product of green and red will be blue, so it's perpendicular to the surface that the two first vectors make. That's very good to know for Unity, actually, but we'll probably not talk about that. Okay, so quick thing. So if I were using scale to merge things together and to flatten things out. So first of all, let's see what happens when two points get so close to each other that they are pretty much merged. Wonder where I can find a good example. Okay, so here we go. See these two lines. First of all, let's get rid of everything else but this wall. So Alt select this, Control plus plus, Z to look through, and C to select or deselect. Right, it toggle selects or deselect. Okay, I don't even need these, this, and that. Okay. Control I to select everything else. Hide. Z to make everything visible. Hide this. Hide this edge. Okay, so you see this wall. This wall right here. If we look at it, it's got 24 vertices. And let's see, we want to get rid of this this band here. So a trick to do that is to select these two loops here and scale them closer to each other. S, Y. Actually, scale them closer to each other by selecting, let's say, the active element, which is the last loop we selected. So S, Y. See how one gets close to the other, and if I pass the other line, we go the other way, but there's like some weird artifacts here. So the closer you get to the edge, the second edge, the closer the two edges are, it works. It works by what was I gonna say? It's like a fraction. So basically, the distance between the first and the second is going to be a fraction of the distance between my cursor back to the first edge. So if my cursor goes halfway between its position and that leftmost edge, and it goes halfway in between, then these two edges will be closer to each other by half, I guess. So let's see. Half, you see that? And the closer I get, you see the closer they get. And if I do that again by zooming out, you see I am making that ratio really small. And once again, SY, let's do that, I messed it up. So SY gets really close, SY again, SY again. You do that a bunch of times and you zoom really far out, and you can imagine that ratio is getting super super small. The distance between the two walls are now like microscopic. But Blender does an extrapolation, which means that when vertices are that close to each other, it'll make like one out of them. It'll merge them together. So, in other words, if I select my entire wall and tell it to remove doubles, where's my remove doubles? You see that I have 24 vertices selected. If I remove doubles, I've removed 6. 1, 2, 3, 4, 5, 6. And now here I only have one vertex. That's it. The other way this could have been done. So scaling really helps. Sometimes you'll be doing that a lot. Another thing that works is merging, but that takes a long time because you have to delete this face, right? You have to delete everything in that loop. Oops. So delete all of these faces. And now you'd have to start stitching. And you select one point, and you select another one, and I think it's Control M, or just M. No, it's Alt M. So at first, where do you want to merge? The 2 points at the first point, the 2 points at the center, or let's see what it is, at the center. They both get merged at the center. So you do that, Alt M, center, and you would have to stitch the entire thing. Merge at the center. It's the same effect. You see, like the first time we did it a lot faster by scaling. Okay, now let's use scaling again for another purpose, and that is let's see, and that is to flatten surfaces. So I use scaling to make things bigger or smaller, but you can also use scaling to get vertices so close to each other that they're pretty much the one and the same, and you can say delete double. Or if I wanted to make a chimney, right? First I would extrude and scale to make a coplanar smaller plane. But now if I were to extrude on the z-axis, fine, it's going up and down on the z-axis, right? But the top is kind of kept its slant. So we're going to use scale again. If I scale this surface on the z-axis, SZ, it'll flatten out. And it's the same trick. You move far out and you scale Z, and you don't pass that point. Of course, mathematically, it'll never be flat, just like mathematically the 2 points that are getting scaled closer to each other will never be one and the same, never be on the same position. But once again, Blender does extrapolate and says that, okay, at this point, this is pretty much flat. That's why Blender is really not an architectural tool, or like it's good for 3D printing if you don't have to make like surgical tools. If this were, I forgot what the other softwares were, well, those like Autodesk, AutoCAD. This would have never happened. This would have told you that this surface is really close to 0. It's like 0.000001, but it's not completely flat. It's not completely 0. Same as scaling 2 points close to each other. You can scale as much as you want. AutoCAD will always tell you it's a fraction. It's not flat. Alright, so this was scaling to do other things than just scaling. scaling to merge points and scaling to flatten things out. This also works really well if you have like, let's say I take the surface, right, and extrude this way, extrude that way, extrude that way, and I want to make this entire thing flat. Well, same thing. Bloop, bloop, and let's scale on the x-axis this time. Oh, I don't really want to make it flat like this because it'll do like an accordion type. Let's make this up. Let's mess this up and this up. Not on my normal, but my global. Yes, just up like this. Okay, let's make this flat, like a flat wall. SX. Oh, sorry. L to select all that. SX. And it's getting flat and flatter. Oh, SX. And if I zoom out and I start scaling from here. Oh, sorry. SX. SX. By this point, oh, I think I went over. Oh, actually, yes. It is pretty flat this way. You see, I've completely flattened it out. It's just that when I was extruding it, it was not perfectly. Well, let's make it. Let's make it perfectly squarish. What I would do is take this, and that, and do SY, SY, and SY. This technique is very important when it comes to texturing, and you will see this will totally help you out in texturing, because in texturing you want to unfold an object into a flat pattern, and sometimes it's never really a good grid, so you have to like recreate a good grid by doing this to a ginormous grid, so it takes a long time. And that's it for now. Thank you for watching. Next, we're going to put this into Blender. Promise.